I've pressed go live, so it should be live. I th
Okay.
I think that's good. Awesome. I th
We don't see you. We don't see you live yet on
you,
YouTube.
you don't see me
No,
live?
not yet.
No.
Tell me when you see it.
Now we do.
Now you do.
Now we see you
Excellent.
live.
So it's going to be live. It's going to have about 10 seconds lag, I think,
Oh, isn't it?
between
Yes.
what we say here and what is going to appear on YouTube. But don't worry about that. We're gonna chat here. We're gonna demo here. I'm gonna run it all as if we're just running it as a normal community sort of call and have a bit of a chat and ask me anything. So anyone who wants to ask any questions, obviously can swing by the Discord and put questions in the Discord, or can join us on voice in the lounge. And anyone who wants to ask questions on YouTube, that should work too, as long as at least one of us is keeping an eye on the messages and spots new messages coming in. So feel free to join the conversation. But let's get into it. So today's chat is all about peer operations. So the peers are the nodes in the Convex network that maintain consensus. In a way, they're the most important things on the network because they're the ones that actually make it work. They maintain the security of the network, and they do all the computation. They do all the state updates. They take care of everyone's digital assets and run all the smart contracts. So pretty central to the whole Convex ecosystem. So today we're going to do a couple of things. Firstly, I wanted to just do a walkthrough of setting up an entire Convex network from scratch. Yeah, so exactly what do you have to run to make that work? And I'm going to do it at the command line and just to show the different commands. But as we go through, I'll explain why I'm doing it and what the different things mean and why you need them. Because it is a little bit complicated and a few people have found it a little bit challenging. So I thought it'd be good to do a proper walkthrough and a proper demo of how that works. And that applies to the obviously to Protonet if you want to set up a peer on Protonet, but it also applies, and I think this is very important because a lot of people are wanting to do this now, if you want to set up a peer for testing, like you have your own little development peer or development test net that you want to use to test your own applications without using the live network. So the nice thing about that is you have unlimited CVM, unlimited control of the network, and you can test what you like without any consequences. So I'll spend a bit of time going through that, but please do come in with questions because this is always more fun if we have a bit of a conversation as we go through. And then after I've done that sort of walkthrough, it'll go more into sort of open discussion. Ask me anything, anything you want to know, anything you want to discuss, and we'll take it from there. Sound good?
Yes.
Perfect. Okay, so let's get going. So I'm just going to do this little walkthrough. So I am starting on just a normal shell. The only thing I've done is I've set up the Convex CLI. Yeah, so I can run the Convex CLI and I can see all the different commands available. And this is all you need to get a network running. The only other thing I've done is I've created a couple of keys in advance, so some crypto keys which are in my key store. I can separately show how to do that, but I've just set up two keys. I'm going to use one for the Genesis to create the Genesis peer and to create and to set up the initial peer on the network, and then a second key which we're going to use to create a second peer and then have that peer join the network, and then they'll be talking to each other and communicating. Yeah. So what do we need to get the network running? The first thing we're going to do is we're going to use a convex peer start, and I'm just going to paste in this command here. So it's convex peer start. I'm saying this minus minus Genesis argument, that is the seed for the Genesis peer. So that is the seed which is used to set up the governance of the network. So if you've got that, that's like the root key of the network, if you like. Now that's a highly secret key. You can see it here if you want to replicate exactly what I've done. but this is not a key that I'm using on any public network, so you know it's no big deal. So I'm saying my Genesis seed is this 32 digit hex number. That's the ED25519 seed, and I've got two other arguments. One I've said minus h equals peer1.db. I'm saying I want to create a database in the file peer1.db. And the reason for that is the peers all use a backing store on disk, which is where they persist all of the transactions and all of the state updates. And they use that for their basically operational database. And the other argument is I've given it a port. So I'm saying use peer port 18888, which is the default port for a peer. And that should be enough to actually create and run a test network. So you can see it says using test Genesis seed, which is the one I just gave it. It's created a Genesis state, and it's given me the Genesis state hash if I want to check that. A few different log messages, most important ones, peer server started on port 1888. That means it's effectively running. Yeah, so that message, once that message has happened, the peer's actually live, and the peer's got this public key. And the other messages, I mean, this is Javelin. So Javelin is like the embedded web server that the peer runs. And it's run itself, hopefully on port 8080. Yeah, it's run itself on port 8080, which is nice. So what I can do is I can go to my browser, and I can go to localhost 8080, and I can see I've got this peer. So I've got the Peer Explorer, and I've got 1 million issued CVM on this network. It's running on localhost 18888. The HTTP is on 8080, and you can see this peer key. That's the peer's public key, this BD9 key. And if I click on peers, you can see I've got this one Genesis peer, which is BD9 A606, etc. So that's that peer key that we've created. And this is in fact 100% enough to do development and testing. Yeah. So if all you want to do is test out Convex, run smart contracts, write some code, do some digital asset stuff, you can totally do this. So I'll just to prove it, I've got Convex desktop here. And I like Convex desktop because it's got this convenient terminal. So I can go in with the terminal. I can go localhost 1888. My address, the default Genesis address for the Genesis account is always 11. And if I connect to that, you can see I am in account 11. I have 390,000 CVM, or near enough. And I can execute transactions. So anything transaction I'm executing here is running on the network, and you should probably, if I refresh this, you'll see that some transaction fees have actually arrived in the peer. Yeah, so they've now got some transaction fees for doing adding 1 and 2. So this is a fully functioning network with one peer for test and development purposes. So nothing wrong with that. That might be all you need. But we're more interested in actually having a network here. So we want to add another peer to this network. So let's assume it's going to be someone different. Yeah. So they're going to have their own key, and we're not actually going to know their private key. So we need to basically ensure that they are able to do what they need to do. So we're going to give them a count. What I'm going to do is I'm going to run a create account command, and the other person, peer 2 operator, has given me their public key that they want to use to manage their peer. So that's just a public key, and I can execute that, and it has created account 132. So that's going to be the peer controller account for the second peer. Now, what I can also do is, because they're new on the network. They haven't actually got any access to any CVM at the moment. I can transfer to 132. Let's be generous. Let's give them 100,000 CVM. Okay, so 100,000 CVM has gone out of my account, and if I switch to 132, I can see that 132 has 100,000 in their account. Yeah, so the same way that you would fund a new account on the network with anyone, it's just I've given them a decent amount so that they'll have enough to do some staking. A question from the audience: how does Convex make its keys quantum proof? So currently there's no quantum threat to any of the cryptography used in Convex. We use ED2355119 for these keys, which is an exceptionally strong cryptographic algorithm using Edwards curve cryptography. It's basically trusted by banks, governments. It's extremely strong. If quantum threat becomes a problem in the future, which it might, it's still quite some way off, we would switch to a new algorithm. So we would support a second type of key that people could use instead of their standard ED25519 key. So it will be an option for the paranoid in the future when the threat becomes significant. At the moment, none of this cryptography is remotely threatened by any quantum computing that's been invented so far. Same applies to the hash functions. So it's SHA-3 256 hashing mostly, and SHA-256. Very strong hash functions. They're pretty safe at the moment. But we'll keep that under review, yeah, if it ever looks like there's any risks. But a good question, yeah, it's something to think about for the distant future. Okay, so one other thing I am just going to quickly do is the peers need to advertise where they are so other peers can find them. So one thing I'm just going to quickly do is I'm going to do set peer data. I'm going to set my URL to be this is on the peer 1. I'm saying my URL is localhost 1888. Yeah. So this is just to help the peers discover each other. And if I go to this peers, yeah, this peers, I can see its metadata. It says URL localhost 1888. So that's good. That's what you want. Okay, so just close my window. Let's bring that back. So let's just go over to 132 now. So 132 is our new user. So this is now peer 2 doing all this. He is going to run a create peer command, and he's creating peer. He's using his own public key as the public key for the peer, and he's giving it 20,000 CVM as stake. So this is how you actually create the peer record on chain. So to have a running peer, you basically need two things. You need the running server, and you need the registration of that peer on chain. So I'm just going to execute that. It says it's succeeded. Let's just double check. Yeah, so I can now see there's two peers registered at the moment. So we've got peer 1 with 199 and peer 2 with 20,000 stake. So it's about 90 to 10 sort of ratio at the moment. Question from the audience: where's minimum hardware, memory, and OS requirements? Well, the minimum is a Java virtual machine with enough memory to run a peer. So it's going to need enough RAM. I think about 1 to 2 gigabytes is sufficient. It's pretty small, in fact. And there's absolutely no problem running multiple peers on one machine or one container. They're pretty lightweight because convergent proof of stake is such an efficient consensus algorithm, and the CVM is so fast. These peers aren't really doing that much work unless you put hundreds of thousands of transactions through them. So It is pretty minimal what you need to run a peer, and I'm just going to run two peers, you know, on my desktop, and you know it's not going to be any problem at all. So yeah, feel free to try. I mean, I'm sure someone could run one on a Raspberry Pi if they wanted to. So I've got the peers registered. Now the problem is we've only actually got one peer server running, so only this first peer is actually an operational peer at the moment. So that's not good. We want a second peer. So I've just started a second window, so we can have that for peer number 2. And what's the chats? What's the chats? Oh, great to see us continuing to grow new heights. Yeah, thanks chat. Thanks chat. Any other messages? Main chat. Okay, just checking the chats. I think we're all good.
Yeah, there's a chat function inside of the lounge.
Oh, okay, yeah, I see it. Yeah, quantum secure keys we covered. Great, awesome, good stuff. Yeah, feel free to keep the questions coming. By the way, I'll spot them as soon as I get them or someone speaks up. So we're launching the second peer. So I'm going to do another convex peer start. Now, this command is a little bit different. It's still convex peer start, but here I need to say where we're syncing to. So the second peer is going to get its information from the first peer in order to bootstrap and get it running. So I'm saying the host is localhost 18888, which is that first peer. I'm also giving it a database. I'm giving etch equals peer2.db. Now, you basically need a separate database for each running convex command because they're separate processes and they lock the file exclusively. So it'll complain if you try and use the same database. But yeah, I'm just giving an extra DB. And I've also said what peer key I want it to use. So if you remember, I've got this second peer which has this this key starting with OX240, and I'm giving it telling it which peer key to use. Now, because it's in my key store, I don't need to type out the whole key. I just need to type out the first few characters, and it'll find it. I'm also saying that my address is 132 because that's the account I'm going to be using as the peer controller. And I'm also telling it the port I want it to use. So peer port equals 28888. And if I fire this off, it's asking me for my key store password. So I'll just enter that. And it has launched a second peer. So we now have 2 peers running. This peer has started on port 288. And it should have a web server as well, so 60501. So localhost 60501. Yeah, so that's a second peer web server running, and you see how fast it is. Yeah, this is incredibly quick, and I'm running 2 peers. It's absolutely no load on the machine at once. So I've got my second peer. As account number 132, I can also set my URL. So for this peer, my URL is going to be 2888. I've got to check here that I'm actually in account 132. If I try and do it for account 11, it's going to fail. Yeah, because I'm not the controller of this peer. Yeah, so I'm trying to set someone else's peer's metadata, not allowed. But if I do it from account 132, that succeeds. Yeah. So if I check this metadata now, I see localhost 2888. And that's it. These peers are now in sync. They're now running. They are. I can execute transactions. Now this terminal opened for the first peer, so just put that up. But just to prove that it's working, I'm going to create a second terminal to the second peer. And let's do that for account Let's do
So
that.
are you sharing the screen? Sorry. Are you sharing the screen?
The screen is on YouTube.
Oh, okay.
Yeah,
So
so I'm streaming on YouTube. I haven't figured out how to share simultaneously on YouTube and on Discord. If anyone's an absolute Discord genius and knows how to make that work, that would be cool for a next time. But yeah, if someone can post the YouTube link, you'll be able to see the screen display. So
there's the link in the chat.
Yeah. Okay, so I'm just connecting to the second peer, so on 2888, joining the second peer. So I've got another window, Convex terminal window opened up, which is actually connected to the other peer, but I can still transact perfectly fine with this. So whichever peer I send the transaction to, it just replicates and syncs and gets consensus across all the peers as it should. And as you can see, like I can just put some timings on these. We're completing transactions in 12 milliseconds at the moment, which is not bad, considering that they're actually running a full consensus algorithm in 12 milliseconds to get to finality. So Convex is pretty much the fastest consensus algorithm in the world at the moment. So it's nice to see these kind of timings and these sort of test scenarios. So that's basically it. And obviously you can just repeat that process for as many peers as you want to add to the network. I can also do things like change my stake. I can change my metadata. If I actually move the URL to a different location, I can change my metadata. I can also destake them and remove the peer if I want as well. So you can sort of evict peers from the network if they're down or they're misbehaving or they don't have sufficient stake. So yeah, so that's the quick demonstration of how to do a full network setup for testing purposes, and how to add a new peer from scratch to the peer network. And what I'll do is I'll post all of the instructions for this on the Discord and on the YouTube, so people can see what the commands I did are. So hopefully that's useful and hopefully that's interesting, and people can use this to try it out themselves and get everything working.
There's a question in chat.
Yeah. Okay. What questions have we got?
Minimum compute.
Minimum compute requirements. I mean, this is. Let me just see. One sec. Task manager. I mean, my CPU is trickling along at about 5%. I'm running OBS. I'm streaming from YouTube. I'm doing multiple things. There's absolutely no pressure on a desktop PC. Let's have a look at the processes. How much are these guys using? So we've got Java SE platform binary, which will be the two peer commands. They are running in about 400 megabytes. This one is using a bit more. Oh, so that's Convex desktop. Convex desktop is using about 400 meg, and that's quite beefy. This is, oh, that's Jedit. Terminal. I'm not sure I believe that. I'm just trying to figure out how I can tell how much the peer processors are running. I mean, it says that the terminal is actually only using 2.4 megabytes, which I think is a bit light for a peer. Okay, I found two more processes. I'm pretty sure they're running at between 200 and 300 megabytes. So a machine with 2 gig of RAM, and a reasonably fast hard disk should have absolutely no problem running a peer, I'd have thought. But we haven't really tested it exactly how low you can go. I mean, obviously you do want a decent machine so that you don't ever run into any issues. Yeah, this is not really using much at all.
So basically, a gaming laptop could handle this easily.
Yeah, I think any modern laptop would have absolutely no problem. We can run peers in very small containers like Docker containers, or a small virtual machine on a cloud service provider. It's really not a heavyweight process at all. So yeah, have no worry about hardware minimum requirements. It's super low. You can probably run one on a Raspberry Pi, I'd have thought.
Interesting. Question in the lounge chat.
Okay, so the question, what's the accounting model? Is it account based like Ethereum? So good question. Yes. So Convex is account based, and when I say account based, I distinguish that from like UXTO or UTXO based systems like Bitcoin, where you don't really have an account. You just have, you just spend it to different addresses, and you have a sort of different address every time you do a transaction. So Convex does have accounts. The main difference in the account model between Convex and most other decentralized technology is Convex has account numbers. So if we look at the terminals that I've just been running here, for those of you following on YouTube, you can see the account numbers. They're like #132. Yeah. And if I do create account and create account with some new key, you get allocated a new number. So here I just got allocated number 133. So the accounts are sequentially allocated. They just count up. I think there's about 15,000, 16,000 on Protonet at the moment. So the earlier you get in, the lower the account number you can get. But the accounts are numbered for a couple of reasons. One, it's more efficient. They're very small. They're only taking a couple of bytes of memory. So having small accounts actually makes the whole system, or small account numbers makes the whole system faster and more efficient. Easier to type as well, which is kind of nice. The other big benefit is the key for the account, so the cryptographic key, is separated from the actual account number. And what that means is I can actually change my key at a later date. Yeah, so if I want to change to a different key because I'm worried that my key's been compromised, I can do that, and I don't have to send all my funds to a different account in order to use a new key. I just continue using my account. I just switch the key to a new key that I know is secure. So it's much more robust to key rotation. It provides basically key rotation features. So the Convex account model is a bit more sophisticated than Ethereum in that sense. Actors, so smart contract accounts, which we generally call actors, they're basically automatic programs running on the CVM. They get their own account numbers too. So they will get allocated an account when someone deploys the code. And there's basically very, very little difference between user accounts and actor accounts. The only real difference is user accounts, you can run a transaction externally, yeah, by signing a transaction, whereas actor accounts don't have a public key, so you can't actually submit external transactions for them. But otherwise, they work in effectively the same way. But yeah, good question, and I think this is quite important because how we manage accounts, this creates a lot more flexibility. Yeah, you can have key rotation, you can have key recovery. We also have this concept called a controller. So you can delegate control authority to another account, which can then manage your account for you. So that's quite a powerful feature. So you could have users having their own account, but then also having an external controller that can maybe do account recovery, for example, if they lose it. Can an account address be given back to the network? That is a great question. So there is no way of removing an account from the list of accounts. And the main reason for that is each account has a sequence number, so it has a nonce associated with the account. And if you want to prevent replay attacks, you've always got to remember that sequence number so you can check whether that transaction is being executed before. So the state always has to keep old accounts around. However, you can absolutely give your account to someone else. Yeah, so if I wanted to transfer account 133 to a different person, for example, I'm just going to need to fund it. I'm just going to give it 1000 CVM just to say 133, isn't it? 133. I'm going to give it 1000 CVM. If I switch to account number 133, I can change that key to a completely different key. So currently I've got that key because that's my own key, but I can do set key, and let's say I put in someone else's key, and I'm just putting in a random one, but someone's given me a public key. I can set key to that, and that has now changed the key on that account, and only the person who's in possession of the new key will be able to control that account going forward. And if I try and do another transaction now, you see it fails. I've got the wrong key. I don't have that key, so I can't actually do anything with that account. So that makes it possible to transfer the account to other people. Now, one of the things that I'd love to actually write, and actually this would be quite a fun project for someone, is a account a recycling auction. Yeah. So if you want to get rid of an account and you want to sell it, or you want to auction it for charity, you give this account to an actor. The actor takes control of the account, and then the actor runs an auction, and then when that account is sold, the actor then updates the key to be the key of the new buyer. So that would actually be quite a fun smart contract, just a little actor that recycles accounts for people. So that's quite a fun idea. You could also have an NFT that grants control of an account. So you could have an NFT that you can transfer around, and then you trade in the NFT to actually get control of an account. So there's a few quite interesting ideas that we can use for recycling accounts. And it's a good idea to recycle them. Yeah, I mean that you get better numbers, and B, it helps to save space on the global state of the network. So it's only a few bytes per account, but every little helps. So you actually get CVM back if you save memory. So because memory has memory accounting costs on Convex. So it's in your interests to use as little memory as possible, and one of the ways you can do that is by reusing or recycling accounts. What makes a dead account? A dead account is one, well, I've just murdered 133 by setting the key to a public key that I don't have the private key for. A dead account is one that has either no key or a key that no one has access to anymore, and also doesn't have a controller, so you don't have any way to actually do recovery using an account controller. So that's one of the reasons, by the way, I recommend using a controller. If you lose your key, you can still recover the account. So yes, so early in Protonet, a couple of accounts got turned into dead accounts because someone created accounts without any keys. and of course they're just going to sit there empty till the end of time as a historical record of what not to do. Okay, so any other questions? Yeah, question from the YouTube chat. Can I talk about what stake is required to run a peer? Okay, so there is a minimum stake of 1,000 CVM required to register and maintain a peer in the global state. So basically, if you want to be on the list, official list of peers in the global state on chain, you have to have at least 1,000 CVM in that peer. And we require that mainly just to make sure that, look, if you're running a peer and you're interacting with other peers, you've got to have at least a certain amount of stake in order to make it operational. We might change that number for mainnet. It's possible we either increase it or decrease it if there's good reason, but it seems about the right level. That's the minimum stake for a peer. You can also have delegated stake, so you can put stake on someone else's peer if you don't want to actually run a peer yourself, and then you get a small share of the peer rewards for placing delegated stake on a peer. So that's a good option if you don't actually want to be a peer operator, but you still want to participate in securing the network. Delegated stake helps out that as well. So yeah. Good question. Oh yeah, so Sebastian, did you want to talk about the Archon sale?
Hey, am I audible?
You are audible, yes. Just speak quickly. I'll just check you're going on YouTube.
Yeah, great. So basically, we at NFT DAO are organizing an NFT collection that each NFT is going to be a voucher for the amount of CVM necessary to run a peer. Actually, a little bit more. Each NFT is going to come with 1024 CVM, right? Because the significance of 1024 divisible by 8 in sort of the storage world. And the idea is that anyone who buys an NFT will be able to run a peer if they wish, or they have CVM to delegate to another peer and start gaining rewards.
Perfect. I mean, that sounds absolutely awesome. I'm very much looking forward to the Archons. So yeah, that's a great package. You get your Archon and enough CVM to stake a peer and be sort of a early guardian of the network. So great stuff. Thanks, Sebastian, for sharing that. So yeah, I mean, and we're definitely going to keep under quite careful review how the staking on the network evolves, because ultimately we want people to be able to do things like stake pools, have a good ecosystem of delegated stake, also have peer operators maybe that are fulfilling slightly specialist roles. So the purpose of running a peer isn't simply to earn peer rewards. It's also because you want to provide a service. Yeah, so a peer, every single peer on Convex, I'll just go to the API page to show it. Every peer on Convex acts as an RPC node for the network. So you can use the API to transact as a client. So if you're building a web app or you're building a DeFi solution, you can actually run a peer and have it as your own RPC node that's serving up an API for it to talk to the network. So if you're actually building that kind of app, you may want to run your own peer just so that you've got a peer in your own data center that you control and you can reliably guarantee that it's being properly operated and all of these kind of good things. So you'll have some peers that are maybe playing that kind of role, and you could also run a peer without any stake, and this is a little bit weird, but you can actually. I'm just going to start one here. I'm going to do join network. So I'm going to join the network at localhost 1888. And when you join the network, you can actually do this, and it will create a peer. And this peer's got this key F16B, etc. Now this peer has 0 stake. It doesn't exist as far as the other peers are concerned. Yeah, it's not in the list of registered peers. But it is actually a peer. It has actually replicated and synced with the network, and it says it's not currently a registered peer, but it's got a connection to the main peer, and I can see all the accounts on the network. Yeah, I can see my account number 133 with 1,000 CVM that I've killed by giving it a key that can't be used. Yeah. So it's actually got the full network state and replicated the full network state. The only thing is you can't use it to execute transactions because it's not a registered peer, and if it sends any new transactions to the network, it won't be recognized. But if you only want to use the network from a read-only point of view, running one of these 0 stake peers is absolutely fine. So that's something that's an option as well. And I can imagine if you're doing like analytics, yeah, you only want to do analysis of transactions, or you want to test things out using a copy of the current network state. Running a peer with 0 stake is perfectly reasonable thing to do. Yeah. So okay. So great point from Rich in the chat. If anyone wants to be a peer operator, we do have a peer operations channel dedicated to people interested in running peers and operating peers in the Discord. So if you join the Discord, then join that channel, and we can discuss all of these kind of topics in more detail there. So yeah, great reminder, Rich, to for people to get involved with the Discord in the right place. Cool. Any other questions on any of the chats? Any other questions from the crowd? Okay, so yeah, I mean, there's lots here. I mean, and the there is plenty to take in, and I know we can probably do a bit more work to make the command line interface a little bit more forgiving. So currently it does complain quite easily if there's anything not configured right, and some of the options are a little bit tricky to get right. So I think we can do some bit. We need to do a bit more work on making the CLI user friendly for doing this. It does take a couple of tests just to make it work. Got some questions. Got some questions in welcome. Fantastic. Okay, so a couple more questions. Christmas message. Thanks to AI and partners for the Christmas message. Hopefully see you in person soon. Fantastic. Any thoughts on decentralized governance of stake? Well, I mean, this is effectively a decentralized staking model. Yeah, anyone can come along and place stake on the network and operate a peer, and that's part of the principle of the network, that it is decentralized. Governance, I mean, we want to make sure that the peer operators ultimately govern the operational functioning of the network. Yeah, so it should really be the peer operators as a community that decide when to, for example, do a network upgrade, and the peer operators obviously choose their own stake, but they should collectively be making decisions where it comes to major network changes. So, for example, let's say we decided we wanted to change the minimum stake. It's currently 1,000, and let's say the peer operators wanted to make it 2,000. Yeah, and there might be some good reasons for that, operational reasons or security reasons. And it really should be up for the peer operator community to decide that between themselves. What is the right thing to do for the good of the network? And you know, and the question says, well, look, you want to make it sure no one person or body can take control. Even if you have the majority of the stake in the network, you can't really control the network, because you still can't change ownership of assets. Yeah, so this peer here currently has 90% of this test network. Now, that's actually totally fine. They have the majority of stake, and they'll get the majority of the staking rewards. But as long as that peer is, continuing to operate, the network's going to be fine. And that peer cannot take someone's assets. It cannot execute transactions on someone else's behalf because if they haven't got the keys. So it's actually the crypto keys are what give the security to assets and transactions, not the stake of the peer. Yeah. So the stake of the peer is really important for operating the network, but it's not actually significant in what the network actually executes and what changes it makes to asset ownership and stuff like that. So it's not as dangerous as you might think in Convex for a few peers to have a high stake. Now, obviously, if you've got a majority of the stake, you can disrupt the network. But why would you do that if you have a lot of stake? I mean, it's sort of shooting yourself in the foot at that point. So, the incentive should be that if you are an operator with a lot of stake, you actually want the network to be running well, because you've got a significant stake in the network being effective and successful. So that's the way that we sort of try and balance the incentives. Oh no, great question. Yeah. So when you execute, the question is, does the client peer get more CVM than others? The answer is yes, as currently configured in Protonet. Currently, 50% of the transaction fees go to the peer that is representing the client, and the other 50% gets shared across the peers. Yeah, so if you are a peer that offers services to a lot of clients, and a lot of clients use your peer to submit transactions, you're actually going to get a higher share of rewards than your stake, because you're getting the full 50% of the transactions that you process. So yeah, there is an incentive for peer operators to provide a good service to clients, because if they do, they get a higher share of that. And that's another reason, like if you're running an app, a decentralized application, then it makes sense to run your own peer, because you're going to get your users to route their transactions through your peer, and you're going to get a higher percentage of rewards. So, yeah, I think it's a good system. And again, this is something that, look, if the peer operators as a community should decide if they want to change that number. 50% seemed right. When I was writing the initial version of the tokenomics code. But if there's a good reason to change that, I mean, we can, and that should be something that the peer operators ultimately have a discussion about. And if there's a sensible proposal to change that, we probably should do it. So that's what I'd like to see in the peer community is good discussions about what the right balance of some of these parameters are, because they are important to get the incentives fair and balanced in the network. So I hope that answers the question. And one more question. When a peer is slashed, what happens to the stake? So great question. So I'd first make the caveat that currently peers don't get slashed. They can lose out on rewards if they become non-operational, but we don't actually currently slash peers for anything in Protonet. Now, again, that might change. We may identify some conditions where peers would get slashed, and if they did get slashed, what would happen is the slashed stake would get basically burnt as transaction fees and would go into the peer reward pool. So Convex keeps a peer reward pool. Let me see if I can just show it. Explorer accounts. Yeah, account 0 actually accumulates peer rewards to be distributed to peers. Now, currently it's quite small because I've only executed about 10 transactions or something like that. But that reward pool basically gets paid out to peers over time. So if a peer got slashed, their stake would get moved from the peer into that reward pool, and then it would be paid out over time to other peers who continue, good peers that continue running the network properly. So again, it's a good incentive. Yeah, peers want to keep each other honest, and if we ever do have a need to slash peers, or indeed slash any kind of misbehaviour activity, putting it in the peer reward pool is kind of the fair thing to do, because then that gets recirculated to the ecosystem via peer rewards. But yeah, great question. So the only other option would be, look, do you get some kind of reward for spotting the misbehaviour or reporting the misbehaviour? So it would be possible to have a sort of finder's fee for people who report slashable activity. But I say we don't currently apply slashing. So this is for future development if the network needs it. And again, that's something I think the peer operators need to discuss and to come to a view on what slashing is most appropriate. Another question in chat: do people staking CVM have any voting rights for peer operations? So there are no formal voting rights attached to staking in terms of governance. Now, this is definitely something we want to, I think, discuss in, like, how do we create the right kind of governance mechanism for the peer community, and certainly, having representatives from the highest stake peers would seem like a pretty reasonable idea, and then maybe have some community vote to elect community representatives, and have a governance committee form something like that. So have a number of different governance roles and a committee that has voting rights, and then they will be able to vote on any proposal to change peer rewards or peer management or peer operations. So there may be indirect delegated voting rights, the right to elect a representative for the peer operations committee. These are just ideas, yeah. This is something that hopefully peer operators can self-organise some of this and work out the best way to operate. I'm going to say we're still in Protonet, we're still quite early days, but we will want to have formal governance on this once we go to V1 mainnet. So, but yeah, good question. I mean, what voting rights should stakers get? And it's actually kind of interesting, because one thing that you don't want is votes to be based on instantaneous stake. Yeah. So if someone just suddenly stakes a ton of CVM, in 1 second before the cutoff, in order to gain a powerful vote, that's a bit unfair. So we will probably want to do it more about having sustained stake over a period of time, and maybe take multiple samples of stake and do an average across them, for example, over a period, to say, okay, over the last 6 months, who's been on average the most highly staked participants. So that's much more robust than letting people make a short-term stake change in order to kind of tip the scales on voting. So yeah, we need to think about some of these kind of mechanisms as well.
Questions in the lounge chat.
Questions in the lounge chat. Too many chats. Okay. Long-term goal for the amount of well-staked peers. So that is a good question. I mean, convergent proof of stake is designed for a fairly large number of peers. I think what would be you expect a Pareto distribution, yeah. So you expect the highest peer to be like 13%, then 10%, then 8%, then 6%, then going down, yeah. So something like a Pareto distribution is probably going to be what the sort of the long-term goal would be. If you have a Pareto distribution, you'd imagine that probably the top 15 or 20 peers would together have 2/3 of the stake, and I think that's a reasonable goal. Yeah, that there's probably maybe 15 or 20 peers that collectively represent the majority of the stake on the network, and I think that's probably what would be sensible. Yeah. As I say, none of the peers can cheat even if they have the majority, so there isn't that much incentive for people to collude and to try and disrupt the network, or they still can't control other people's assets or funds or smart contracts. So they really are just simply interested in running the network as efficiently, as effectively as possible. And yeah, but I could easily see there being, as I say, maybe 10 to 20 well-staked peers with the majority of the stake, and then like a long tail of much smaller peers that obviously contribute to the network, but aren't so important in terms of staking. Okay, great question. How will data lattice work with peers? So for those who aren't familiar or want the refresher, Convex is a global state machine. It has on-chain smart contracts, actors, digital assets that are maintained as part of a global state that can interact with each other, and everything can do atomic transactions and transfers between them in a sort of robust, bulletproof way that everyone can see on a public network. Now, the data lattice is designed to work off-chain, so you don't actually have to put it on the public network. You don't have to have any transaction fees. You can share it peer-to-peer without only publishing things to people that you want to share with, etc., etc. So the data lattice is much more flexible. The data lattice doesn't need peers. You can run the data lattice without referring to the peer network at all. Here I talk about Convex peers, yeah, peers that are actually staked on the Convex network. Now, that doesn't mean that the data lattice or applications using the data lattice might not look at the stakes. Yeah, so you could easily see that, let's say you would trust someone who's running one of these peers probably more than you would trust, a random IP address on the internet. So there's a potential for peer stake to be used as a assurance or as a sort of roots of trust on the data lattice. And one idea is, look, in the peer metadata, so we previously put sets of metadata for these peers with a URL. We can definitely have multiple things in that metadata. One of the things that they could easily have is like a data lattice address, and that data lattice address then becomes a root of trust for the data lattice if you want to start replicating parts of the data lattice. So that's a good way of having a root of trust, because anyone who's a peer and is a peer controller and can make changes to that metadata is by definition sort of trusted on the network, because we we know that they've got a stake in the network. They're operating a peer. They have a vested interest in making sure that the network runs smoothly, and you know, they're probably not going to be particularly interested in running a scam. So that's a possibility, to have a way that the peer trust can be used on the data lattice. Otherwise, the data lattice, as I say, can run completely independently of peers. It sort of has its own. It's more flexible in terms of it doesn't have to reach global consensus. Yeah. Oh, another question. So, are there any cool features that peers have or will have as we move towards the agentic economy? That is a really good question, and I'm glad you asked. I almost forgot. One of the things that I think is super fun is every peer, you can now have the option of your turning your peer into a MCP server, and this is absolutely amazing. So we did another video recently where we actually ran some of these. Oops, my Chrome's freezing. That's not very good. Come back, Chrome. There we are. So we actually had AI agents running transactions on Convex via Model Context Protocol, and it was fantastic because they were able to transact, they were able to query the network, they could write code, they could interact with smart contracts. We actually got them to negotiate a contract and actually negotiate payment for some work performed. So you can have agents paying agents to do any other thing, and it works absolutely natively with any Convex peer. You just have to enable this MCP feature, which currently is on by default, and you've got an MCP server. So for those who don't know, MCP is Model Context Protocol. This is the sort of API protocol that AI agents use to talk to external systems. So any AI agent can now make use of Convex via this API, and yeah, it works. It's very powerful, and I think one of the most amazing things is because Convex has an on-chain compiler, which is pretty unique. You don't actually need to write any and deploy any code. You can just execute code directly on the network through a transaction, and that really is powerful for agents because they know how to write code. They can very quickly write the correct code to achieve whatever task you want to do on Convex. And most things on Convex are just one line of code anyway. Yeah, so for a model to write one line of code and execute it via MCP is actually pretty trivial for them. So I can do a separate community call on MCP and sort of demoing the agentic features perhaps. But yeah, it's absolutely important for peer operators. If you're planning to run a bunch of agents and have your agents conduct economic transactions, you may want to run a peer as your own MCP server. Yeah, so that you can link all your agents up to it. So okay, yeah, sounds like we've got some votes for talking about MCP on the next call. So yeah, that's something to save for next time. But thanks for reminding me. It's very exciting stuff, and we've got a separate video out sort of demoing some of that. But we'll do a community call on that as well because it's very interesting stuff. Okay, I don't see any other questions. I think we're sort of going a little bit over. So hope everyone's found that interesting and useful, and you know, maybe learn something about how to run a peer and how peers operate, and how the sort of vision is shaping up for peer operations in the Convex ecosystem. So I'll share some links on the Discord and on the YouTube channel, and I'll also share the instructions that we use for the demo today. Thank you very much all for joining, and if I don't see you before then, have a great Christmas. Bye for now.